Hi, this is Mr. Max. I'm doing paper one of 2025. This is the Namibian Advanced Subsidiary level. Of course, um, I'm continuing on my series on working out the question papers. Right. As per usual, um, you always advise to read the instructions carefully. You know, a lot of times you might hear or you might read that we are saying, or in the question paper they say, you should give an exact numerical answer. In such cases, either your answer is in terms of pi or the square root or something or a fraction or so on. But then when the answer is not an exact numerical value, then you're encouraged to use the correct or the given specific rounding that is here. That is either to three significant figures, or if it's angles, you give to one decimal place. This is when the angles are in degrees, but if the angles are in radians, then you give two, three significant figures. Right, for pi, you either use your calculator, use your calculator value. Also, one more thing that you need to understand whenever you are attempting to do questions here, it's imperative that you understand the relationship between when you are using radians and when you are using degrees. So typically, when a domain is given in radians, then you probably have to give the angles in radians. But there are one or two questions in here that we are going to do, and you will see exactly that I would give either or answers in degrees or radians. Right, so we start with the very first question. It says, given that the equation kx squared plus 2x plus 2 minus k is equal to 0, and then they tell you that k is a non-zero integer, very important, show that this equation has rational roots for any value of k. Now here's the thing, this boils down to the discriminant. Now I have a few things here, or a very interesting table with regard to discriminant. So one of the things you should take note of, the question here says, and this is your hint, that the roots should be rational. And I have the three conditions here. The discriminant is greater than 0 if there are two possibilities. So can you see here, if it's rational, I'm expecting a perfect square. So that means my discriminant should be greater than or equal to 0. Okay, that's what I'm expecting to get there. But if it's just saying it's irrational, then you just use greater than. Well, if it's equal to, it means that it will be equal. If it's less than, it means there are no real roots or solutions. So I'll keep this table here. And this part of the table is the part that comes in handy for you to know that you are going to use this condition. So what is the discriminant? It is nothing but b squared minus 4ac. And we are saying it should be greater than or equal to 0. Our b value in this, if you look at it nicely, okay, I'm just going to say that the discriminant for now is equal to, well, that's 2 squared, this is the value of b, minus 4. Our value of a is a k here, so that's going to be k, and our value of c is that 2 minus k, so this is all c, so that's 2 minus k. Okay, so we're expecting whatever we're getting here to be a perfect square. All right, so this is very important whenever you are told rational roots. So our a is k, our b is 2, and our c is the quantity 2 minus k. All right, that is what I'm using there. All right, let's clean this up. This is going to give you 4 minus, so you have got negative 4k times 2. Well, that's negative 8k. A negative times a negative is positive 4k squared. This here is a perfect square trinomial, okay, unless you want me to clean it up a little bit, taking out, or maybe rewrite it as 4k squared minus 8k plus 4. And then I'm going to take out the 4 as a common factor. I have got k squared minus 2k plus 1. Okay, should be very familiar at this stage on how to factorize that. And if you do that, you're going to have 4, and in bracket, this is a perfect square trinomial of the quantity k minus 1 all squared. And because of that, All right, and because of that, really, I can actually say for any value, um, for any value of the discriminant equal to or greater than 0, okay, and also it will be a perfect square. So you can see that whatever the answer should be in a perfect square. And you can try. You can look at, they are saying that k is a non-zero integer, so k should not be 0. Um, but if you do put any value here, whether it's -1, whether it's 5, whatever the value of k is, as long as you square, that becomes a square, a perfect square. And whatever you do to a square, when you multiply it by 4, the result will still be a perfect square. So that is what um, you were supposed to do in this particular question. Right. So I'll keep this handy. You can pause the video and you can sort of, write this down for you whenever you get questions on the describing the nature or the roots of a quadratic equation. All right. Then in the case where k is equal to 5, find the set of values, and the key word here is set of values. That means you are going to be dealing with an inequality, as you can see here. So when k is 5, so that's going to be 5. Everywhere over k, I'm going to substitute it with a 5. All right. And then in here, you're going to have 2 minus 5 less than 0. So just clean this up. This is 5x squared plus 2x, and 2 minus 5 is -3 less than 0. Now, in order for you to be able to handle this, I'm going to look for what is referred to as the critical values. But I just want to talk about this function here. As you can see, suppose this was our x-axis like so, and this is a parabola, and that parabola is going to take this type of shape, okay? And this is our x-axis. Whenever we are dealing with a scenario like this, we are saying the whole of this function is less than 0. What does that mean? It means the whole of that function is below the x-axis. So our set of values that we are going to be looking for would be the values that are joined by whatever this range here will be. So in order for me to find that range, I need to find where I put my dots there. I can say that's a A and I can say that's a B. So I need to find what we refer to as critical values. But I do understand my answer will be a range, right? With extremes. So to do that, I'm going to let this be an equation. Let 5x squared plus 2x minus 3, let that equal to 0. And you're going to attempt to solve in order to find those critical values. And at this stage, I do expect you to be able to factorize this and be able to solve it. And if you do, you're going to have 5x squared plus, maybe you can go directly, plus 5x, okay, plus 5x minus 3x minus 3, that will give you 0. So at the end of the day, I have 5x outside of x plus 1. I have -3, I have x plus 1 equals to 0. So from here you have what, 5x minus 3 in brackets, as well as the common factor of x plus 1 in this old bracket. And anything equal to 0 imply that 5x minus 3 is equal to 0, or x plus 1 is equal to 0. Right, so at this level, I do expect you to be able to solve this. This is x equals to 3 divided by 5, or 0.6, or this is x equals to -1. So what is my solution going to be then? Well, because I found my critical values and it's below, so the big number comes on this side and the small number comes on that side. That is the set of values that you are going to find. Right. So because the inequality, the whole function is below 0, it's negative. The only time when you have the whole function to be negative is when it's below the x-axis, because anything above the x-axis is positive. So you use this, making an equation in order for you to find the critical values, my A and B, as you could have seen, and then you keep the inequality there it was without the or equal to. Right, so I have written question 2 here. Of course, you will be able to see that I haven't changed the the overall question itself. I just wanted to create a little bit more space for myself the way I explain this. So you have, maybe I'll use 3 steps. It's totally up to you how you want to go about solving this question, given the coefficient of x cubed in the x function of a plus x all to the power 4 minus 1 plus x over 2 all raised to the power 5. They say that expansion, that coefficient is 3/2 of a. And we were supposed to find the constant a. Now let me take this a plus x expansion raised to the power 4. So what it means that this term here should be an x cubed term. That's what it means, right? In order for me to find that coefficient. And I have got another term a here, so that a term, right, it has to be power 1 because the two of them should add up to that 4 that I have over there. I'm just going to rewrite it nicely, okay, so you can see. So that means this x has to be a cube, therefore this one should be whatever you're adding to get that. Now, here is one more thing that you need to consider. Suppose I'm bringing in Pascal's triangle, which you don't need. Okay, suppose you bring in Pascal's triangle, and I'm going to go all the way and end here where I have a 4 because, I'm starting with 4 now. So this is going to be 6, 3 plus 1, that's 4, and so on. That's what I'm going to end with this one. So we are now looking for the coefficient of what is going to be here. That is from your binomial theorem. So this is n choose what. So it has to be 4 choose something, whatever this value will be here, right? And that 4 choose something has to come because you'll see that it has to be the third. So this one that you see here in Pascal's triangle, this is 4 choose 0. This is 4 choose 1, and obviously you can calculate this. This is 4 choose 2, and this is 4 choose 3. So that's what I'm looking for. All right. So I know that this is going to be 4 choose 3, which is something that I can calculate. So this 4 choose 3, this is the coefficient that I am going to use. So at the end of the day, I'm going to have 4, and then I have ax cubed as an answer there. All right. So the coefficient of the x cubed term in this binomial is 4a. Right. So I'm going to do the same for the other one, which is, maybe I just use a different color. The other one here, which is 1 plus x over 2 raised to the power 5. Okay. Now again, what we need here is I need that this x plus 2 expansion, right? This x plus x over 2 expansion rather, I need that to be a cube. And what it means as the other one, the one here, should be raised to the power of 2 because the two of them should add up to that 5 that I have over there. Right, but I need the coefficient. And what that coefficient must be 5 choose something. So 5 choose what? So let me just continue with Pascal's triangle. So that will be 1, and this is going to be a 5 because this is raised to the power 5. That's where I'm going to come. But obviously, you will see that there's no need for you to do that. But let me just continue for now. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5, and 1. So this is 5 choose 0, which is going to give you 1. Of course, you can use a calculator, right? I hope you still know how to do that on the calculator. So I'm really interested in the coefficient. 5 choose 0, that is obviously just going to give you 1. Okay, can you see that? So even if I do 5 choose 1, that's going to give me 5, which is this one here. So this is 5 choose 1, which gives you 5. And 5 choose 2, that is going to give me 10. But I'm looking for 5 choose 3. So this is the 10 I'm looking for. Why am I taking 5 choose 3? Why am I taking that? Because the term that I'm looking for is a coefficient of x cubed and x cubed, right? So that x cubed, that 3, and this one should be identical. So what is 5 choose 3? Of course, I know from Pascal there that it's 10, all right? And then I can play around. 1 raised to anything is just 1. This is x cubed, so multiplied by x cubed over 8, because 2 raised to that power is 8. Well, you can clean this up. If you do, you're going to get 5 over 4. So this is 5 over 4 x cubed. Now, I have my two sort of, coefficients that I was really interested in that I'm going to use, all right? So that is one way of then looking at it. So what is it that I'm going to do now? So now it becomes really straightforward. And I'm going to go to my place for the answer space, and I'm going to take those coefficients that I just worked out. The first one was 4a x raised to the power of 3, and they say if you minus with the other one was 5 over 4 x cubed. This should give me 3 over 2a x cubed. That's what it says, right? So I know where my 4ax cubed and 5 over 4x cubed is coming from. Now that I have that, I can actually go ahead, because I'm looking for the constant for the value of a. Now to do that, I can drop these x cubes. This is going to be 4a minus 5 over 4 is equal to 3 over 2a. Right, so you can actually go ahead and say, let's have all the a's to one side. So this is going to be 3 over 2a is equal to 5 over 4. So effectively, I'm just rearranging my equation, right? So please remember, this is just the same as 4 minus 1.5. So if you do that, you say 4 minus 3 over 2 is the same as saying 4 minus 1.5, which is 2.5a. All right, so I'm going to write it as 2.5a over here. And this is 5 over 4, and 5 over 4 is nothing but 1.25. So now in order for me to find the value of a, you'll just be dividing both sides by 2.5. So a would be 1.25 divided by 2.5. And you can try it. So you have 1.25 divided by 2.5, which is a half, effectively. So therefore, the value of a is a half. And that is what they were looking for there, and that is your solution then to that. Also very important that you must also remember, they say find the value of the constant a. Okay, right. Let's go to the next question, and this question deals with 3D vectors. Now, they are saying relative to the origin, the position vectors of A and B and C are given, as you can see here, respectively. But what they are saying is, they are saying that P times OA minus OB, it should be perpendicular to OC. So that means if I dot it with OC, they must be perpendicular. Right, so I'm going to do that. So I'm going to do, the whole thing together, and you can just sort of bear with me. So in vector OA, I'm going to multiply every term there by the P. Okay, so that is going to be negative 3P, with bit over 4P and 2P. I'm not going to stop there. At the same time, they want me to minus OB. So I'm going to minus negative 3P minus 3. So I'm going to have a minus 3 here. I'm going to have 4P minus negative 1, which is going to be the same as plus 1. Okay, double negatives. Then I have 2P here minus 2. So minus 2. All right, this is effectively what this is. I'm going to dot this with 5, negative 3, and 6. And because I'm doing the dot product, I'm going to let that equal to 0. And I hope by now you're very familiar how to do that. You simply multiply the corresponding elements and add. So it's going to be 5 times negative 3p minus 3 plus, and then obviously you can decide to put negative 3 times 4p plus 1 plus 6 times 2p minus 2, and because they are perpendicular, the dot product should equal to 0. So your job is actually more or less done. You just have to clean up what they have. So here you're going to have negative 15p over here minus 15, then you have negative 12p minus 3, then you have plus 12p minus 12, and then you say that equals to 0. What is it that we are seeing? Well, we are seeing that certain terms are cancelling. The 12p, the minus 12p and the positive 12p, they cancel. And that is going to leave me with minus 15p minus 15 minus 12 minus 3, okay, equals to 0. Now, if you look at these numbers, you're going to get minus 30. So at the end of the day, you have minus 15p minus 30 is equal to 0. This becomes a very straightforward linear equation that you should be able to solve. So this is minus 15p is equal to 30. Therefore, p will be 30 divided by minus 15, giving me that p is equal to negative 2. Now, of course, you can, can do other things in order for you to find out negative 2. You can take out a common factor here at 15 and at 30. Effectively, you should still get the same answer. Right, so just to go back, you realize that I have done, the P times OA minus OB in the same, sort of same matrix here, as you can see. And then from there, I know that I must dot it with that. And to find the dot product, when you're told that the things are perpendicular, then the dot product should equal to 0. Okay. Now there's a B part to the question. They say use a scalar product to find angle AOB. Now what I like to do when I do this, I like to draw what I have. Okay. So this is angle going towards. They will go towards that. Okay, never mind that. Right, so let's just write. So this is angle AOB. Now can you see that the angles, they either go towards, the arrows, they go towards that, or they go away from each other. That's how you're going to find. So what is it that you need to do? First, you need to find the magnitudes. Since I'm going towards O, I have AO. So I'm going to find the magnitude of AO. And when I'm done with the magnitude of AO, I'm going to find the magnitude of BO, right? Because they are going towards that. That's what I'm going to do. Right, so let me just go and get AO and BO. But remember, they are given as position vectors the other way around. So I'm just going to take a snapshot of them. Okay, and I'm going to paste them over here. Just here, because I just need it. Right, so I want you to take note. This is OA. So if I go AO, then the direction is changing. So if I have AO, then this is positive 3 now, then this is negative 4, and this is what? Negative 2. It doesn't matter when I do the magnitude, but it will come in handy. All right, it will come in handy. So let's see, what is BO? BO, the direction is changing. So this is positive 3 becomes a negative 3. This is a negative 1 becomes a positive 1. This positive 2 becomes a negative 2. Now, for me to find the magnitude of AO, right, it's totally up to you if you want to put these negatives there, because you're going to use Pythagoras anyway. So this is 3 squared plus 4 squared plus 2 squared. So what I'm doing here, I am not putting the negative stuff in brackets because I know I'm going to get the same answer. If you clean this up, you're going to get the square root of 29. The same when I come to this one, BO. I don't have to worry about the negatives, right? It's 3, 1, and 2. because you're going to square. Anything you square anyway will be positive. So it's 3 squared plus 1 squared plus 2 squared. Okay, square root of that. And what does that give you? Well, that's 9 plus 4, okay, which is 13 plus 1, which is 14. So this gives you the square root of 14. Now I have what I have. So what is the next thing I must do? Right, the next thing I must do, I must find the dot product. So I must dot AO dotted with BO because it's in that order. Can you see why this is now helpful? So again, you're going to take the two corresponding elements. So I'm just going to write them here. 3, negative 4, negative 2. I'm going to dot that with negative 3, 1, and negative 2. So you multiply corresponding elements and add, multiply and add, multiply and add, and we're going to see what that dot product is. So we're going to have 3 times negative 3 plus, well, I'm just going to say negative 4 times 1 plus negative 2 times negative 2. Okay, so this here is negative 9, this here is minus 4, this here is plus 4. At the end of the day, my answer is negative 9. One more thing here before I do anything, and I hope you can watch previous videos of mine, okay, or even question papers that I solve. If the dot product is negative, like in this case, okay, like this is negative 9, the angle you are looking for is going to be obtuse. The angle is angle AOB, okay? Angle AOB is going to be obtuse. Very important. If it was positive, the angle would be 1. It would be acute. If it's 0, it's 90 degrees. Right, so what is the formula? Remember, you can find the formula in the formula sheet, right? But you should know it. If you want to find, you use cos theta is equal to A dotted with B over the magnitude of A times the magnitude of B. So what I have my dot product of the two, which is negative 9. I know that I have the magnitude 1 was square root of 29, if I was not mistaken. And the other one is the square root of 14 times the square root of 14. Right, so all this can give me a value, which means that my angle AOB, and this I'm just going to leave it as theta for now. That is going to be the inverse cosine of whatever this business is here, minus 9 over square root of 29 times the square root of 14. Okay? And I'm going to punch that onto the calculator and see what I get. And because they haven't been specific, this is one of those questions that you are going to leave your answer in degrees. Okay? So this is the inverse cosine of, I have negative 9 over root 29 times root 14. Okay, remember I told you that this angle is supposed to be obtuse, and here equal to, there you go. So at the end of the day, can you see that our answer will be obtuse? Right, therefore, now I can say angle AOB is equal to 116.5 degrees. Now, it doesn't really matter in these examinations whether you give your answer in radians, you will still be given the same solution. Okay, you'll still give the same marks if you want to change these to radians. Okay, let's see if oopsie daisy. Right, so let's just see. So this is in degrees, so that's 1. And I need this to be in radians, so that is 4. So if I hit equal to, and I say what is this answer in radians, okay. What is it in radians? 2. Okay, shift, what is it in degrees? In degrees. All right, let's see. There we go. Okay, so yeah, you can also, I'll definitely go back. You can also give the answer in radians, of course. You can play around with your calculator in order for you to be able to give it in radians, but it will also be accepted. Okay, so in this case, you could also say or 2.03 radians. But again, I'm emphasizing this is one of those questions that you leave the answer in degrees. Okay, right. I'm just going to scroll back so that maybe you can have an idea. As you can see, the angle is given as AOB. They must go towards O, and the moment you go towards O, AO, BO, then you have to find the magnitude of AO, BO, and then you must also dot AO with BO. Okay, and then you can complete and find the dot product, and then obviously you can go ahead and find the angle. If the dot product is a negative number like here, I know the angle I'm expecting is going to be negative. Excuse me. Good. Now, let's come to question 4. Right. That brings me to question 4. I had a little itch in my voice, so had to pause a bit. Hopefully it's better. So let's see how it goes. Now, it says the equation of a curve is equal to 3 minus 2 sine 2x, and the equation of a straight line is equal to y equals to minus 2x plus 2 pi, and obviously you can see that this is going to have a negative gradient, so that line is going to slope in this direction, so to speak. Okay, so yeah, I wonder, maybe I must just bring in an extra page, append a page here, because there's a few things that I just want to clarify. Okay, now I'm going to put it up here. Let's see if we can just take a snapshot of this question for you to be able to see what my thinking would be. All right, I'm just going to put it up here. So, number one, just a few things that I want to make sure that they are kind of clear to you. The sine curve and the cosine curve, but the sine curve in this case, it oscillates between 1 and negative 1, okay, from the parent graph. You should know this, okay? So if you have the parent graph, you have the parent graph, the sine graph, it oscillates between, 1 and negative 1. That's what I mean. Okay, now, what I'm looking into is if that is the case, I'm going to do a few things with this function. So take y equals to 3 minus 2 sine 2x. Okay. One of the things, because I told you it oscillates between something, so let's see where will it cut the y-axis, because a normal sine curve will cut it at 0, starts at 0, but this is not going to be the case, okay? So where it intercepts the y-axis, this happens where x is equal to 0. And if you say 3 minus 2 sine 2 times 0, that is going to give you where it will intercept the y-axis. And it will do so at y equals to 3. So I know this graph is going to be at y equals to 3. So if I started. Another thing, there's a minus in front of the function, so this is going to be reflection. So when you have an original function for the sine graph, right, where you have it as starting off from here and going in this way, right, this particular graph is going to be having the opposite. Because of that negative, it's going to be reflected. So it going to go down here, goes up again, and does that. So that's what you expect. So if this is going to be like the graph of y equals to minus sine x, that's the black one. So I know my graph has to take that shape. And also, I know that it has to touch the y-axis at 3. Okay, so now that that's the case, I would really want to know where this graph is going to oscillate between. What will it oscillate? Okay, so let me just show you then what I mean by that. So I'm going to take the function 3 minus 2 sine x, and I say it has to oscillate between 1 and negative 1. Okay, effectively just trying to, isolate that function 2 sine x. Now I'm going to subtract 3 from both sides. Okay, so I'm going to have negative 4 over here, and that is going to be minus 2 sine x, and that is going to be negative 2. Now there's a little problem here. Sorry, I'll have to divide by this negative 2. And to do that, whenever I divide by negative, this signs will change, okay, directions. So I'm going to change the direction in a bit. So I'm going to divide by negative 2 and divide by negative 2. This is going to give me a 2 over here. And as I said, I'm going to change the signs in a bit. Of course, the function here is sine 2x. So I'm just going to write 2x in there. It doesn't matter. Sine 2x. And this is going to be 1. So clearly it doesn't make any sense for it to be like this. So you need to be able to swap it around. So I'm just going to swap around the numbers in order for it to be true. Okay, so it has to be sine 2x is going to be less than 2 and greater than 1. Right, so that 2 and that 1 comes in handy. So it tells me my graph. If I now have to draw my graph, one more thing. So supposedly, okay, so what I have so far, supposedly, let's say here is my graph, okay, and let's say here is going to be the x-axis. Again, as I told you, the graph is going to start at 3. So if 3 is over here, all right, so that's where the graph is going to go, but it's going to go down, right, and go this way. Now, I want to know, it's going to oscillate between what? So it's going to be 2 places. So I add 2 here, so it's going to be 5 here, all right? That's what's going to happen. And obviously, you're going to have to go down 1 place here. So this is going to be, again, as I said, it's going to be between 5 and 1. So my 1 will be here. So the distance between them must be the same, right? So from 3, you have to add 2 to get to 5, and 3 minus 2 gives you 1, because that is what you have, right? So that graph. So that is basically what I know. So I'm going to start off like that. But there's one more thing, and that's that 2 in front of this x that I haven't yet explained. And that is called the period. And the period of the sine graph repeats itself after every 2 pi radians, which is 360 degrees. So the period of my graph is going to be 2 pi divided by 2, which is pi. So that's one thing that is very important. So now that I know that, so I just want to show you a rough sketch of what I expect. So I expect my graph to, let's say, half of that, half of pi. Pi is here. So half of that is what? It's pi over 2, right? And I can go further. This is 0. Half of that will be pi over 4. And this is going to be 3 pi over 4. Okay, so my graph is going to oscillate. It's going to come down. But remember now, my 1 is my sort of my boundary, my lower boundary, and that is the upper boundary. So it's going to come, my 4 points that I will have, obviously I'll have my 0 here. Then I will definitely come up here. Then I'll definitely come up there. Then this is going to go all the way up to that. And this is going to go all the way up to here. So that graph that I'm going to draw is going to go something like this. This is what I'm expecting, okay, for that graph to look like. Very important that you understand that. So for me now to say, for you to know where this graph is going to oscillate between, it has to be 2 units from 3, so you go all the way up there, all right? It has to be 2. It's exactly the same units there, so it's going to be between 1 and 2. 1 and 2. Okay, now that I have that, I think I'm ready to sketch my graph. So my middle line is here at 3. So same distance, it should be the same distance, and that distance is 2 units here, 2 units up there. Okay, and where is that 2 coming from also? That 2 that you are seeing. Now I haven't, maybe I must also impose that so you can understand. Here's the function. Can you see this 2 over here? So if you have a graph y equals to 2 sine x, and you have a graph y equals to sine x, so it's going to be a fundamental change. This 2 here, it affects the amplitude. You get what I'm saying, right? It affects the amplitude. So here the amplitude is 1, so this one is just going to go between 1 and -1, right? This one is 2, so from your middle line, which is the line y equals to 3, I need to go 2 places up and 2 places down. That's what I mean by that. All right, so I'm going to have my graph that I can actually start. So let me just say I'm going to have, this is my y-axis over here, and this is my x-axis over here. And I know, my goodness, you must just bear with me. This is going to, hopefully it's going to save, okay, and we can retrace our stuff. It's going to be interesting. So just bear with me for me to find this particular graph, so to speak, or to find this. Just bear with me. You know, it's one of those things. Technology. Okay, 2025 paper 1. I think I got it now. So let's just open and see. In 2026, we're going to try to invest a little bit more and update all our stuff so we don't struggle with this type of software. Let's restart. Right, let's just make that a little bit bigger so you can see what is it that I've been hinting. Of course, I spoke about the middle line. Maybe I'll make it a dotted line. So it's 3. Let's say we put it over here. Okay. I wish I could change the color. Then the other one that I had my 5 over here. I had my other one, because it's supposed to be 2, my 1 over here. It's not totally how I want it. Then I also divided, so I'm going to divide this into 4 parts, and you'll get an idea why. Always do that. So that's going to be part 1, 45 degrees, or pi over 4. That's halfway. That's pi over 2. That's 90 degrees. Okay. That's 3 over 4 pi. Okay. And then that is going to be 180 degrees. Right. It's not perfect, but it's something. So let's just go and complete. So what I have my 3 here. I have my 5 over here. I have 1 over here. This is obviously 0. This is halfway, which is pi over 2, because the period of the graph is pi. This is pi over 4. You are dividing it as pi over 4 plus pi over 4 is pi over 2. Pi over 2 plus pi over 4, that is going to give you 3 pi over 4. Okay? 3 pi over 4. So I would like to do that. Right. We said our graph is going to start over here when it's 0. And it's come down here. You see my 4 points that I have? Then it's going to go there. Then it's going to go up here. And that's going to come up here. That's how this graph is going to look. So let's get ready to draw this graph. So it's going to be something that goes something like this. Comes down. More or less. Okay, more or less. So I can actually go ahead and label this. This is the graph of y equals to 3 minus 2 sine 2x. Got it? All right, you can label our x's if you want to. Not if you want to, you have to. So this is x, and this is the y-axis. Right, should not be a little bit, it should be a little bit, curvy, but you'll do it much better. Right, then we have sketched that. Then they're saying, on the same diagram, sketch the graph, the line. Now, here's the thing about this line. The line is y equals to minus 2x plus 2 theta. If x equals to 0, then y will equal to 2 pi. Okay, so 2 pi is about 6 point something, right? 2 pi, that gives you about 6.2. Are we together? So that line is going to cut the y-axis at about 6.2. So 6.2 is going to be, if you agree with me, it's going to be about somewhere here. So this could be my 2 pi value. Can you see that? So that's what it's going to be. Right. Where is it going to cut the x-axis? It's going to cut the x-axis if you make y 0. So if you have minus 2x plus 2 pi, if you say let y equals to 0, you solve this equation. Eventually, I do expect you to be able to solve this equation. Okay. To get the value of x, which is minus 2x is equal to minus 2 pi. You can drop the negatives, and then x will be equal to pi. So again, this graph is going to cut the x-axis at pi. Okay, so it's going to cut the x-axis at pi. So that is where that line is. Right, my graph is not to scale, but it's going to go something like so. There's that line. Okay, because I said on the same. So I can actually go ahead and say this is y equals to minus 2x plus 2 pi. Not so bad. Okay, not so bad. Not so bad at all. Right, there's just a few things that you need to be able to take care of whenever you are sketching sign graphs and so on. So I spent a bit of time there just to clean that up. But at this level, we expect you to be able to do that. Right. Then for part C, use your graphs to determine the number, and the word number here is bolded, of real roots. Basically, where these two graphs are equal, it means where they are intersecting between 0 to pi radians, and as you can see, they intersect here at pi over 2, but we're not looking for the value of pi over 2. We're not asking what that angle is, what that x value is. We are saying how many times does these two graphs intersect, and you can see it's just one, so you can just say one solution. Okay, one real root, one solution. That's all. Nothing more than you could do there. Right, so hopefully your curve is going to be a bit smoother than mine, and there are many ways and shortcuts on how you can actually draw these curves, but you should have an understanding of how the curve should look like, especially this one being a reflection, and that 3 telling you that the graph is going to cut the y-axis at 3, and remember that 2 in front of the function tells you the amplitude is going to be 2 times, so 2 units from your mirror line, which is the line y equals to 3. 2 up gives me 5, 2 down gives me 2, 1. And then you can draw this and have the 4 points or 5 points that you can actually plot. Your graph is going to pass through those points. At 0, and the other one here, and so on. You plot them, and that is where it's supposed to be. So you can see that is why I made that grid looking thing to guide me a bit more, so that my graph can look a little bit more accurate. Okay, so I think we are ready to go to the next question. The next question says 3 geometric progressions, P and Q and R. R is not here, but they say they are given such that their sums to infinity are the first 3 terms respectively of an AP. Sorry, what does that mean? For progression P, if I want to know the sum to infinity of this one, I will say, okay, you know the sum to infinity formula? It's A over 1 minus R. from this, A is 36. R, well, R can be 36 over 13 divided by 36, and if you do, you get 1 over 13. Then for Q, okay, so basically I know that. So before maybe I look at Q, let me find what is the sum to infinity then of the first of P. So the sum to infinity, right, of P is going to be A, which is 36 over 1 minus R, which is 1 over 13. Okay, you can grab your calculator, so let's see what it is. So it's going to be 36 over 1 minus 1 over 13. Okay, that is 39. Okay, so the sum to infinity, that is 39. That is for P. So let's do the same thing for Q. For Q, the A value, because we're still working with sum to infinity, right? A is equal to 30 is here. R will be, let's take the second term, which is 30 over 11. Let's divide it by the first term, which is 30. And if you do so, the 30s will cancel, leaving you with 1 over 11. Okay, AS level student, I expect you to be able to do that. So what is the sum to infinity of Q? It's going to be A, which is 30 over 1 minus 1 over 11. So let's see what we get. So that's 1 over 11, and then over top there must be a 30, if I'm not mistaken. It's 33. So what do we have so far now? Now we have, because they are now saying that the sum, the first three terms, they form an arithmetic progression. So we know what P is. So term 1 is equal to 39. Term 2 is equal to 33. So term 3, okay, term 3 will equal to R. What will our R be? Now it's very easy. There is a common difference here, which you find by saying term 2 minus term 1, which is the same as 33 minus 39, which is nothing but negative 6. Okay. We also know what is our first term. Our first term is 39. So I can actually find R. R is going to be 33 minus 6, which is going to be 27. Okay. Now I know my value of R. They are saying find the sum to infinity of the progression of R. R is equal to 27. Sum to infinity of R will be 27. Quite interesting question. Very tricky to an extent, but actually, if you understand the concept, then you do not have a problem. Okay. So through and through, you have to apply the sum to infinity formula. Right. There is a B part. Now they're saying, hence find the sum of the first 15 terms of the AP. Here we go again. All right. So now that we know what the AP is, it's been a while, so just bear with me. When I do paper 2, I'm going to try to see if I've updated all my software. Please do provide and make the channel stronger. Okay. And yeah, then I can post more content like this. Right. So what do we know? The sum of the first 15 terms will be 15 over 2, we have a bracket, 2 times our A, which was 39, remember, and then plus 15 minus 1 times D, which is negative 6. Please make sure that you do understand, you recall the formula. Okay, I'm just going to write the formula somewhere here, so you can have it. Sum the number of terms is n over 2, and then you have 2a plus n minus 1, minus 1 looks bad, and minus 1 times d. Okay, so that's basically the formula that I'm using. Right, if you were to use your calculator, you're going to get negative 45 as an answer. That's it. Right, so basic stuff, or stuff that you have learned in grade in grade 11s or the lower grades, okay, in order for you to know. I'm not talking about sum to infinity, but I'm talking about the sum of the series. This one. There are two, but this one is straightforward. Right, the next question. Prove the identity sin x plus cos x times 1 minus sin x cos x, and you should prove that they're identical to sin cube x plus cos cube x. So I'm going to take the left hand side and I'm going to multiply. So I'm going to expand the left hand side, okay? So I'm going to multiply this times that, which is going to be sin x. Then I'm going to take that times that, which is going to be minus sin square x. Then I'll take that sin x, okay, minus sin square x cos x, okay. Then I do the same, change the color maybe. I'm going to take cos x times that, which is just plus cos x. Then I have this times that, it's going to be minus sin x cos square x. Very important. Now, from your basic trig identity, the one of sin square x plus cos square x that you know is identical to 1, you should know that there are two more that you can get from here. And we know that 1 will be, I'm just going to write it, see where I have space for it. Just going to write it next there. We know that I have sin square x is going to be 1 minus cos square x, that's 1. Another one is, I'm going to write it over here, cos square x is identical to 1 minus sin square x. Why is that important? Because here where I have sin square x, I'm going to replace it by 1 minus cos square x. Okay? And where I have cos square x, I'm going to replace it by that value. Clear? So let's continue. So I have sin x minus, remember here I said I'm going to replace sin square x by 1 minus cos square x times cos x plus cos x minus sin x, and I'm going to replace cos square x by 1 minus sin square x. Now, I'm going to multiply out the brackets. This one here might be a little bit confusing, so I'm going to bring that cos x that is at the back of the bracket just in front, 1 minus cos square x. So I'm just rewriting it to make it a little bit easier for you to see what is it that I am doing over here as I'm distributing into the bracket. Okay, so now I have sin x, then I have negative cos x, and a negative times negative is positive cos. Okay, goodness, I'm saying positive and I'm not writing it. So it's plus cos cube x, hope you're following, cos x times cos square x is cos cube x, plus, well, cos x is there, I have minus sin x, if I distribute that, and a negative times negative is a positive sine, you guessed correctly, cube x. Now, there's a bunch of things that are happening here, and I hope you can see it. So I'm going to bring in my highlighter, excuse me. This sin x and this one will cancel. Something else cancel. This cos x and this one will cancel, leaving me with, ladies and gentlemen, drum roll, cos cube x plus sine cube x. Right. And what is the right hand side? Can you see the right hand side was sine cube x plus cos cube x? So we effectively have proved, and then we say this is identical to the right hand side. There we go. Okay. So the ability to play around with colors is quite helpful, and yeah, you will not have a problem with that. Quite a straightforward identity, if you ask me, to prove. Right, there is a hence to this question, and there is a relationship. The moment they say hence, you must know, okay, there's a relationship. Realize that relationship must be whatever you have in part A. So we already know that sine x plus cos x and multiplied by 1 minus sine x cos x. We already know that that is equal to, um, there we go. We already know that this is equal to sine cube x plus cos cube x is equal to 28 cos cube x. That's what we have. So I'm just going to rewrite and put the 28 cube x on the left. 28 cos cube x. Say that is equal to sine cube x plus cos cube x. Let's collect like terms, will we? So 28 cos cube x, 28 cos cube x minus cos cube x is equal to sine cube x. This is going to be 27 cos cube x is equal to sine cube x. Interesting. Now I'm going to divide throughout by cos cube x. I'm going to divide cos cube x here, and I'm going to divide cos cube x here. I could have divided by sine, but that will imply me because I can see something happening, right? That and hopefully you can see. On this side, I'm going to be left with 27. Here, sine over cos is nothing but tan x. Now I can actually find. It's much easier to work. So therefore, tan x is equal to 27. Angle x. This implies that angle x is going to be the inverse of, is it? The inverse of 20. Good. Let's just not make a mistake there. That is still tan cube x. Right. Still tan cube x. Now we need to get that cube gone there. So this basically is the same as 10x cube is equal to 27. That's what it is. To get rid of that, you'll take the cube root. So this is tan x is the cube root of 27, which is tan x is equal to 3, because the cube root of 27 is 3. Right, so angle x, therefore, is the inverse of that, of 3. So let me just go see what domain are they giving me. What are they giving? Yeah, it's degrees, okay? So the domain is in degrees, calculated should be degrees, and then the tangent is going to be positive in 2 quadrants. So I expect to have 2 solutions here, okay? So let's find my acute basic angle. Make sure calculator is in degree mode. Always make sure of that. Okay, back and forth as you are attempting this question on AS level. The inverse sine of that. Of course, that is what it's giving me. So just take screen capture. I'm just going to write that down there. Now, I have 2 solutions. One solution is x is equal to 71.6 degrees. But I have another answer. And this is in the, hopefully you remember from your cast diagram. Okay, so that angle, this angle we are now looking for is all the way up to here. How do you find that angle? You say x is equal to 71.6 degrees plus 180, because in the third quadrant, tangent is also positive. Okay, so add 180 more, 251. So I'm just going to capture that, bring it over here. So effectively, my 2 solutions then, I'm going to come here and say, therefore, x equals 71.6 degrees, okay, or 251.6 degrees. And the domain is in degrees, so the answer is given in degrees. Most probably, as they are marking, they might condone you giving the answers in radians, but that is what this question entails. So quite interesting how you approach it in order for you to be able to calculate the angle. Right, question 7. The function f is defined by f of x such that x maps onto 10 minus 2x minus 8x, 2x squared minus 8x, for x is greater than or equal to a. I'm just going to rewrite this function because I'm going to rewrite it as y equals to minus 2x squared minus 8x plus 10. And I'm going to write it in vertex form. I'm going to bring that 10 over this side. Okay. Just follow what I do. Okay, I'm going to bring it back later. Don't worry, it's not gone. And I'm going to factor out minus 2. That is going to leave me with x squared plus 4x. Very important that you get that. Then from completing the square, I know that this is going to be x plus 2 all squared, and in here there's going to be a plus 4 which I'm going to take away as well. So I'm now left with y minus 10 is equal to, multiply that negative 2 into both terms, it's minus 2, x plus 2 all squared, negative 2 times negative 4, that is positive 8. Now I'm going to bring back my minus 10. And if I do that, I'm going to add it back. So effectively, this statement, because I did more, I need this space, so I'm going to just write it over here, is now minus 2x plus 2 all squared plus 18. But I want it in this form over here, so the 18 must come in front. Therefore, I have 18 minus 2x plus 2 all squared. There we go. That is the solution. Of course, you can do it many ways, but for me, that works. Yeah. Now, this is important that you understand something from writing something in vertex form, like here, the one on top. It tells me the turning point, and the turning point is important. I'm going to just write it down, although it's not required in this question. The turning point is the opposite of whatever this is, so it's going to be minus 2, 18. This is the turning point of this graph. That means that what you have over here is going to get this value. The place of the A, that's what you're going to get. Okay? So that implies they are saying state the smallest value of A. So A will be equal to negative 2 because it's greater than or equal to. So the smallest value is negative 2. And that's the solution here. Very important. There's nothing, to be afraid of there. The 18 plays a role. And this is what I want to explain with that 18. This function, it will, here we go again. Yeah? I definitely have to save this before I lose all of this work. Before I lose all of this work. Let's restore and let's continue. Okay. Let's see what happens when I save it. I'm just going to save it as a stuff like that, of course. Right. What I wanted to emphasize as well from this vertex form, because this vertex form, it gives me a very indication, a clear indication okay, of how that function would look like. I'm just going to post it here. There's a reason I do that. Okay, that function is exactly equal to this function that I wrote over here. They are equal, the same with f of x in that mapping notation. All these are equal. They are equal, right? If I was to sketch this function, because the value of a is negative, this function will go all the way like this. This will be the turning point. The x value of the turning point is x equals to -2. The y value is 18. So if you were to graph this, the range is going to be y will be less than, because you see the function goes down, y less than or equal to 18. That is how the range of this function will look like. That is the highest point. It's going to be 18, and then from there it goes downwards. Okay, so this function is what we call a maximum. All right, and you know, from that is why in the lower grades you were given functions like this, and then you were told to graph them for you to have an understanding of how the functions would look. Okay, clearly I'm just quickly going to sketch it for you, or I'm going to draw it here on GeoGebra. So it's y equals to, okay, what was that function again? If we go back, minus 2x, or it doesn't matter how I write it. You can write it like this, or I can write it like that. Doesn't matter. Okay, so I'm going to write it minus 2x squared minus 8x plus 10. So minus 2x squared, okay, minus 8x plus 10. Right, it goes a bit haywire, but can you see the highest point here? Can you see the turning point that I was talking about? The turning point is happening at -2. The graph is going to the left. Here's a thing you should know about this function. If your value of b here on the function, okay, if the value, it was minus x, minus 8x, so if that is going to be negative, the function is going to the negative side. Can you see that? So the function will be sort of translating to the left. Turning point is -2 for x, and that is the highest point. So the domain, the range is from here up to negative infinity. It goes down, right? So that is the range of the function. So y is less than, or f of x is less than or equal to 18. That's what we are referring to there. So that's what that means. Now they say for the value of a found in part B, this one here, you need to find the inverse and state the domain. Now I don't need to do the second part. The second part doesn't really depend on the first part here. Why? Because I hope you understand that from functions, that if you know the domain of the inverse, the domain of an inverse is equal to the range of a function. What is our range? Our range was y is less than or equal to 18. So our domain then, we have to use x. X will be less than or equal to 18. So you have actually answered that without you doing the whole of that. Okay, so that is taken care of. So we can actually come to part B, where we're now going to take that y equals to 18 minus 2, and then we have what, x plus 2, that whole function. We're going to make it, it has to be in vertex form for you to be able to find the inverse. So let's switch around the letters. X equals to 18 minus 2, then have y here, plus 2 or squared. Now we're going to say, okay, subtract both sides by 18, and then you're going to divide by -2. Please be with me and follow what I'm doing. Now another thing also, when you have scenario like this can be written as, I'm going to write it like this: y plus 2 all squared is equal to 18 minus x over 2. because I'm just putting the negative now on top there. And if I put brackets there, then the negative is going to make the x a negative and the 18 becomes a positive. It's essentially the same thing. Now I need to get rid of that square by taking the square root. So y plus 2 is equal to the square root of 18 minus x over 2. But see, I didn't write plus and minus here. Okay? I didn't write plus and minus. Now I wrote it, of course. But I'm not going to write the plus and minus. If the value this is given to us, x is greater than, okay, for that value, if it's greater than, that turning point, if it's greater than or equal to greater than, then it's a positive here. If it was x is less than or greater than or less than, then it would be a negative. So here must be a positive value. So if you make y the subject of the formula, you're going to get that y is equal to 2. That 2 becomes now a negative because you're taking it over, right? Plus the square root of 18 minus x over 2. But we're not looking for y. We are looking for the inverse. Therefore, the inverse is going to be negative 2 plus the square root 18 minus x upon 2. And that has solved that question. So we have solved this part where they ask us to find the inverse, okay? And also the part where they were asking us to find the domain of the inverse. There we go. The domain of the inverse is equal to the range of the function. Hopefully you're with me so far. Question 8, a curve is such that dy dx is equal to 6x squared plus k over x squared, where k is a constant and the curve passes through that point Q. Then they are saying for 1 mark, always look at the mark. It tells you what is it that you need to do. Okay. So, yeah, they are saying the gradient at Q is that. So, 6, what is our x? X is 2. Plus k, what is x? X is 2. The gradient is 22. That's it. From here, just, solve the problem. 2 squared is 4. 4 times that is 24. Plus k over 4 is equal to 22. Okay. Then you have k over 4. 22 minus 24 is negative 2. Therefore, k equals to negative 8. That's it. Bear with me. Make sure that you understand. Okay. Now they are asking us to find the equation of the curve. Right. So if we know the derivative and we want to find the equation of the curve, we have to do the antiderivative. And the antiderivative means we need to integrate. Okay. So I'm just going to write the gradient that is given to me. I'm going to write the gradient here. dA, is it dA? The gradient dy dx. The gradient function dy dx is 6x squared. Now remember k is negative 8 now, right? So that is going to be negative 8 over x squared. So that's going to be like plus negative 8 over x squared. I'm just going to rewrite it so it looks a little bit better as 6x squared minus negative positive minus 8x to the negative 2. That is the derivative function. So to find the function, I would say the function y would be, we integrate, okay, 6x squared minus 8x to the negative 2, and we integrate with respect to x. Now I can integrate, but I will need a point. But I'm given a point q because I will need the constant of integration. The point q is given to me as the point 2, 9. So I'm going to use that point to find the constant of integration later. So let's integrate, and hopefully you still know how to integrate. The function becomes y, add 1 to the power, it becomes x cubed, divide by that power. Add 1 to the power becomes x to the negative 1, divide by that new power, plus the constant of integration, which is plus c. So let's just clean this up. This is going to be y equals to 3 into that, that's 2x cubed, negative and negative, that makes it a positive 8. Okay, that x is raised to the power of negative 1. I'm just going to put it down here, plus c. Now I'm going to substitute for x and for y, right, when I can find my constant of integration. Y is 9, x is 2, plus c. If you play around, you're going to see that you're going to get a value of c, which is negative 11. I'm just going to pause there so that you can calculate it, okay? So this is 2 cubed, which is 8, times 2, that is 16, okay? And then you have plus 8 over 2, whatever result you have, take it to the other side, you're going to get c equals to negative 11. So therefore, my equation is y equals to 2x cubed plus 8 over x minus 11. That is the function. So when you are given the derivative, you find the antiderivative by integrating in order for you to find the equation of the curve. And then you need the point in order for you to find the constant of integration. Okay, that brings me to question 9. The diagram shows a wooden block. It's very interesting. Now, it's again, it might look like a complex scenario, but it's not. You can see that they are saying it's in the form of a prism lying on a horizontal ground. The base is an equilateral triangle, and you should know from an equilateral triangle, to find the area of an equilateral triangle is a half times the two sides, in this case is x times x, which is x squared, times the sine of what is the sine of that angle, which is 60 degrees. Because this angle here will be 60, and there will be 60, and there will be 60, right? So that is how you find the area of this shaded part. And if we need to find the total surface area, I'll be multiplying this formula by 2, okay? So that is basically going to help me with the area. So maybe I can do that. You know, the sine of 60 degrees, and I do expect you to know that, it's a half, okay? Is it root 3 over 2? So the sine of 60 degrees is root 3 over 2. So this is a half x squared times root 3 over 2, for example. This is going to be root 3 over 4x squared. This is the shaded part for one of those triangles. If it's 2, I'm going to say times 2. Okay, just had to bring it out there. Right, but we don't have h to find the whole area there because they won't want us to express the area, total surface area, in that form. But we are given the volume, and the volume is equal to 432 cubic centimeter, right? We need to find h. That's what we need to do, okay? So how does the formula work for a prism? It's the area of the cross section, which is this formula over here, okay, times the height. That's it. The area of the cross section, which is what we have here, okay, this is area of cross section times the height. So area of cross section, so the volume is equal to the area of cross section, which is root 3 over 2x squared times the height. Times the height, I'm going to say, put a dot here, h is equal to 432. So our objective is to make h the subject of the formula. And once we do that, you should get that h is going to be 1728 over root 3 x squared. Okay, So you have to be a bit, um, just to make sure of something here. I hope you have seen it. That's 4. Right. I just wrote it wrongly from here where I got it. Right. So I'm going to show you step by step to calculate what I did. Okay. So I say, okay, wait a minute. 432. I'm going to multiply it by the inverse of this. I'm going to multiply it by 4 over root 3. Of course, it's going to give me that answer like that. I don't really want that answer. So I'm just going to say 432 times 4. That gives me that 1728. And then I'm going to divide it by that root 3. And I'm also divided by x squared because x squared is on top there, right? So that's my h. Now that I know what my h is, how are we going to find the total surface area of this wooden block? Now the total surface area will be 2 of these. You agree with me? 2 of these. This one here at the bottom, one on the top. So total surface area, I'm just going to say area, is going to be 2 of the one that I have, root 3 over 4x squared. So let's change it. Root 3 over 4. 2 of them. Then how many rectangles are you counting? The rectangle I'm counting, they will be 3. XH, XH, XH. All of them identical. X times H. So 3 of that. So it's 3. It will be 3 X, but they are multiplied with H. But what is my H? From here, H is 1728 over root 3 x squared. So it's just a matter of cleaning this up a bit, okay? 2 goes here 2 times, so I have root 3 x squared over 2. This x and that x will leave 1 x under. 3 times 1728, that is going to be 5,184 over root 3 remains there, right? Root 3, but then again, this is x squared, that's x, so it's going to be root 3x. This is A. Are we close to, what is it that we needed to prove? Okay, let's see if I bring it down. Yeah, it's given by, let's hope that it holds. Let's bring it just to take a snapshot of what is it that they wanted us to do. Good. Bring it here. Come here, boy. I'm just gonna paste it here. And again, there we go. Same old song. Let's hope it restores. Let's go back. Open. Hopefully we can restore. Okay. Restore. And let's make it a bit bigger for you. Are they identical? Yes, they are. So we have done that. Now, this is a 4-mark question. If you are not able to do all of this, you should still be able to do the second part of the question. But at this level, that's what we expect. You're given a diagram. You'll have to create a formula. It's either volume or area or whatever they give you for you to find one of the missing letters in order for you to use that letter into your other formula. And that is basically what we did there. And then from there, you continue. And as you show all of that, so you do continuously get marks. For this particular question, although the solving it is very similar, like to all types of questions of this nature, it just a little bit with the cube root, you have to be careful. So you do not then go ahead and work out, the cube root of 3 and so on, because it could be very confusing. And I would rather suggest that you leave your answers the way that they are asking them. Root 3 everywhere across it, it's like that. So before you even attempt to do it, look at how you should leave the answer, and then you take it from there. Okay, so this is continue to part B. I'm just going to paste that again. They say given that x can vary, find the value of x for which a has a stationary value. In order for you to do that, you have to do differentiation. The moment they say stationary value, it means dA dx dA dx should equal to 0. So we have to do differentiation. Now, if I want to do differentiation, sorry, my goodness, I'm just going to rewrite this. A equals to root 3x squared, nothing I can do there. But here, it's 5184 over root 3. But this x can be written to the power of -1. Now I can differentiate that. Finding the derivative, and then I'm going to differentiate and let that equal to 0, right? So dA dx, okay, take 1 away from the power, okay, take 1 away from the power, so you're going to take 1 and divide, so 2 times, the 2 comes here, so 2's will cancel. You're left with the square root of 3x here, that's going to be a negative, okay, negative times that is going to be the same, negative 5184 over root 3, but now this is going to be x to the -2 because we are minusing 1 from the power. So all of this I have to let it equal to 0, so I'm just going to say, okay, therefore, it's just a bit of algebra that you need to do. Calculus is done. So 5184 over root 3x squared, I'll put here, should equal to 0. Okay? If you multiply both sides by this stuff, root 3 times root 3 will just give you 3. Alright? X times that will give you x cubed minus 5184 is equal to 0. Because what you are doing is you are multiplying both sides by, don't know where to put it for you, by root 3 times x squared. So you're multiplying this by root 3 times x squared, that gives you 3x cubed. Multiplying this to cancel, anything with 0 just gives you 0. So from here, you will realize that this is a cube number now, that x cubed will be 5184, because it becomes positive, divided by 3. Now we know what it was when we divided by 3. It was nothing but 1728. The value of x, therefore, has to be the cube root of 1728. Therefore, x is equal to 12 centimeters. Okay, that's the cube root of 128. You can verify, and then you have it. Okay, so again, I would advise you to make sure that your algebra is very sound. Okay, take a look out for those things. Your algebra is very sound. Okay, now let's take away those. They say determine whether the stationary value of A is a minimum or maximum value. Second derivative, or you can use another method. You know, there are many ways. I will do the second derivative, show you working. It's 2 marks. Now, what do we know? We know that dA dx is root 3 x minus 5184 over root 3 x to -2. That's what we know. Yeah. So the second derivative, what is it going to give me? This is just notation. D square dx square, second derivative, obviously taking 1 away there, it's going to give you root 3. Then you're going to have a negative times negative is positive, bringing that to, okay, that is going to be 2 times this whole thing. That's twice of that. It's 10,368 all over root 3. Obviously, you're taking away 1 from the power. That's going to be x -3. Now, what happens now? So, I want to see the second derivative when we are saying x is equal to 12. What are we getting? Good. Let's see. Let's bring my calculator in. So everywhere when x, I'm going to replace it by that number there, right? It might be a little bit too much for my pro calculator, but let's see. Root 3 plus, up here I'm going to have 10,368 over root 3, and I'm going to have times, I'm going to have brackets here, 12, and that is going to be raised to the power of -3. Let's hope it can, it can find me a value. Ah, there we go. Alright, so let's bring that value there, copy. Now, I'm down. Now, as you can see, from here, we can see that this is clearly greater than 0. And if it's the case, is that second derivative is greater than 0, it's a minimum value. Okay. I'm going to do something interesting, and I'm going to use this calculator. You might not be allowed, they might not allow you to use this calculator. So I'm going to find the second derivative, okay, of this. So I'm going to derive this. The moment I derive this function, which is like 3, and then it's x, alpha x, and then what do we say? Minus, bring a fraction in, 5184 over root 3, might not allow you in this calculator, alpha x raised to the -3. Then x should be 12. Let's hit equal to. I think I made a mistake somewhere. Root 3x minus 5184 over root 3. It should be -2 over there. So that should be -2. See how easy it is if you can make a mistake. Huh. Guess what? We got the same answer. 5196152423. Of course, this calculator might not be allowed in your exams because you need to show all of your working, because they have been very specific in the instructions. Show all necessary working. Right, that brings me to question 10. So we have a little bit of circle geometry. Since I'm dealing with circle geometry, I like to write down certain formula. Of course, you can find them in your formula sheet. So find the area of a sector, that is a half r squared theta. The other one that I like to also write down for myself is the arc length is nothing but the radius times theta. I like to write those things down. Okay. Right. They are saying the diagram shows a sector A or B, center O, radius. My goodness. Let's see. I knew it. I'm going to finish this paper regardless, And then I'm going to invest a little bit more and see if we cannot improve on the software. Okay. I just want to bring the diagram down. It's small, I know, but it's going to be helpful. I don't have to go back and forth. One thing I want you to see, obviously they tell you all the information that is there. We are supposed to show that R is equal to 3R. So my takeaway would be to find the distance O to C. I'm just going to draw it in here. So I want to find the distance from there to there. Are you with me? So there's a triangle there. There's a triangle. This over here is R. This over here, guess what? It's 90 degrees because it is a tangent to radius. Okay? This is going to be half of pi over 3. And half of pi over 3, pi over 6. So this over here, pi over 6. This is OC. So I'm looking for O to C. You with me? And I can use my trig ratios. I'm looking for the hypotenuse. I have something opposite, so I'm going to use the sine. So what does the sine say? The sine of pi over 6 is equal to, the opposite is R over OC. So to find OC, I would say OC is going to be whatever that radius is. Okay, it's very, very important because the sine of pi over 6 is a value. Okay, OC would be, think of this thing over 1. So I'm just going to squeeze it there over 1. So if you are cross multiplying and then you are dividing, it's going to be R over the sine of pi over 6. That's what you're going to get if you cross multiply it. So, okay. So what is our value then going to be when we do that? So let's quickly see. If you know that the sine of pi over 6 is 1/2, but if you don't know, let's fine. Let's just change this to radians. So the sine of pi over 6. And I hope you know this from your special angles. It's 1/2. So this is effectively R over 1/2. Then you can get rid of that by just, multiplying both top 2 by 2 and so on. The 2's cancel here. Therefore, OC is equal to 2R. Get it? Okay? So, if this distance here, I'm going to write it in blue. If this distance here is 2R, then I want you to consider another distance. And that is the distance from here to F. And that distance is R as well because it's a radius. So then O to F, can you see that? Will be equal to R. And O to F will equal to 3R, which is also equal to R. So therefore, OF equals to OC, okay, my diagram, OC plus CF, obviously, which is 2R plus R, which is 3R, okay? Therefore, R equals to 3R. Win it. There you go. So we had to do quite a number of things in the diagram over there in order for us to be able to do that, okay? From the distance to there, where that distance is, and the distance from there to there, and it's opposite. Right. And then all realizing that that is the same, radius, big radius, bigger circle. So that brings me to the second part. Find the ratio in the simplest form, in the simplest form of the area of the inner circle. Okay, so the area of a circle, a circle is pi r squared. Then the area of a sector is a half r square theta. That's what we know. Okay. So when you're looking at this one here, the circle is just r, the radius is just r. So I'm going to say, let's hope I can paste. Okay, make it a bit smaller. So in this case, if I have to say the area of the circle, it's pi small r square. Compare that to the area of the sector. Now the sector has got this pi, okay, the big radius of the sector, okay, it's a half. Remember, it's a half. The formula, it's a half. And what is the big radius? The big radius is nothing but 3r square times the angle. The angle here being times pi over 3. So let's see what we get when we clean up here. This is 9, okay, a half times 3 squared. It's 9. Let's take a calculator. I'm gonna ignore, you know, so just to show you what is it that I'm doing here. I'm gonna ignore. So I'm gonna do this on the calculator. I'm gonna say a half times 3 squared times 1 over 3. Are you with me? Because I know that r should be squared, and I have a pi also that must be multiplied. That pi times r there. So I want to find the numbers. Okay, what will the numbers give me? So the numbers is a half times 3 squared, which is 9, times 1 over 3. What does it give me? 3 over 2. Good. So my ratio is pi r squared compared with 3 over 2 pi r squared. Now, this coefficient here is 1. I can actually go ahead and I can drop this pi r squared. My ratio is 1 versus 3 over 2. And from grade 8, you should know how to simplify this ratio. Okay, same denominator, 2 over 2, 3 over 2. Then you cancel. Okay, many ways to do it. Therefore, it's 2 parts to 3. That is the final answer. Right, so there are many ways you could actually tackle it, but that's essentially what it means, okay? And then this is like 3 marks anyway. Hope that makes sense. Okay. Right, that brings me to question 11. I think this is the second last question. Question 11 deals with the diagram shows part of a curve y equals 13 minus x squared and y equals to 36 upon x squared intersecting at point A and B, as you can see in the diagram. The x-coordinate of A is represented by a small letter a, and the x-coordinate of B is represented by a small b. We're supposed to show that for unknown mark, okay, nothing here to be afraid of. Let's just wait until the thing decides to go back, because I've been scrolling it, but it's going its own way. It still does. Okay. Show that the roots of these are equal. So the only thing that you need to do here is just take the two and let them and equate them. Okay. As usual, I can't believe this is a record. It's been a while. I haven't used it in a while, but it is a record. So we're just gonna continue. You know, I know it. Maybe you can also pause it. Definitely helpful. So I'm gonna say 36 upon x squared. 36 over x squared. Let that equal to 13 minus x squared. Put out 13 minus x squared in brackets. Okay. Then multiply throughout by x squared. This is going to be x squared times 13 minus x squared is equal to 36. Then it's 13x squared minus x to the fourth minus 36. Let's say equals to 36. Let's move everything to the right. Okay. So if we move everything to the right so that it can look like this, that is going to give us x to the power 4 minus 13x squared plus 36 is equal to 0. That's it. So you equating it, simplifying and establishing. That is what we need to do there, and then we have got it. Now they're saying solve by substituting x squared equals to k, or otherwise I'm gonna leave it up to you. You can do the substitution, the k substitution, but we are now going to look for the values of a and b. I know where this question is going. It's gonna probably go ahead for you to integrate anyway, so that's why you made that. So it's gonna either be find the volume of revolution, or no, you're gonna have to find maybe the area between that. Okay, so that's why we need to find those limits, so to speak. Right now, if you want to use k square, you can go ahead and use k square. Maybe I should write that down. So that will be k square minus 13k, okay, plus 36 equals to 0. Because this x to the power 4, this is like x square. You with me? Okay. So that's what that is. All right. And here I've replaced it with a k, and here I've replaced it with a k. That's basically what that means. Okay. Right. This quadratic here, this becomes k minus 9 minus 4 k minus 9 equals to 0. So you'll have k minus 4 and you'll have k minus 9. Okay. But we're not looking for k. So I'm going to have x squared minus 4. I can actually go ahead and let that equal to 0. Or x squared minus 9 equals to 0. Now, I need to be able to find the values of x, so I'm going to say x squared is equal to 4, or x squared is equal to 9. Now, when you are taking square root, you're going to have a positive and a negative value. However, the question is very straightforward, tells you that the values of the constants should be positive. So we are only going to take the positive. Then, so x is going to equal to square root of 4, which is 2, or x is going to equal to square root of 9, which is equals to 3. So therefore, you can actually now complete. You can say our a, if you look at the diagram, a will equal to 2. So you go back to the diagram. Our a will be 2 over here. Okay. Our a will be 2, and our b will be 3. Okay. And b will equal to 3. That's it. Okay. Then they say find the area of the shaded part. So I'm just gonna take a snapshot of this, and then I'm gonna bring it over here, and yeah, make it a little bit smaller. So there are many ways you can do it, but as you can see, the curve y equals to 13 minus x squared is on top. So I am going to apply the concept of I must integrate. So I'm going to say I'm going to integrate from 2 to 3 of 13 minus x squared, because it's on top, minus the other one, 36 over x squared with respect to x. Now, you can obviously do it two ways. You can take 13 minus x squared dx minus, the grade from 2 to 3 of 36 over x squared dx separately. All right, let's integrate. Maybe I can just rewrite. I don't like this fraction here. So that is going to be 13 minus x squared minus 36x to the negative 2 dx It's easier. And then from here we can just go ahead and say, okay, what is it going to give us? So adding 1 there is going to be 13x minus x cubed over 3 minus 36. So now that is going to, adding 1 is -1, so it's going to be a plus now. Okay, adding 1, so it's -1. -1 times that is going to be plus 36 over x. 36 over x. Please make sure that you understand that. Okay, we're going to integrate from there to there. Okay, so now it's just a matter of substitution. So that is going to give me 13 times 3 minus 3 cubed over 3 plus 36 over 3 minus, let's put brackets, let's bring another color, and I have got 13 times 2 minus 2 cubed over 3, good, plus 36 over 2, right over. And you can go ahead and punch all of that in your calculator, see what that gives you. Okay, very important. You should see. Okay, let's see. Let's take this part first. So I've got 13 times 3, which is 39, minus bracket 3 cubed over 3, plus 3 going to 36 12 times. I'm just going to plus 12 minus open bracket. So I'm going to go to the other part now. 13 times 2, that is 26. I'm going to say 26 minus 8 over 3. So 8 over 3 plus half of that is 18 plus 18, close, hit enter. 2 over 3. That is the answer. The answer is 2 over 3 because this is area. So we're going to say square units. Okay. Right, there's a lot in there, but it is what it is. And of course, it should not be very difficult for you to, once you know what is it that you are doing, then you can just go ahead and solve that. Right. This brings me to the very last question of this paper 1. So do be standby or be on standby for paper 2. I'm going to do quite a few adjustments to my software that I'm using here, and then I'll post it a bit later, but it will be available. These videos will be available in February or in late January. Okay, we'll have them, and then 2026, and then you can do your revision. So there's a few things that I want to do when it comes to a question like this. The obvious ones is what I expect you to know. You should know that the diagonals, because these are rhombus, okay, they bisect each other. Not only do they bisect each other, but they do so at 90 degrees. So that means if this is 1, and this is 1 then whatever this distance is going to be the same there, and this two distances will be the same there. This midpoint here, that's going to be the midpoint. So I can find midpoint. I'm going to call that M. So the midpoint, horrible. The midpoint is the same as adding the x values together, because we've got a and c now. So you say -1 plus 7 divided by 2, find the mean. Then 3 plus 7, find the mean. And that is 6, half of 6 is 3. And and that is 10. Half of 10 is 5. So that point there is the point 3, 5. Okay. So let's see if we can blow it up a little bit to make our diagram a little bit friendly. And I'm going to write here, it's 3. And this is my M. Now we also know that they are making 90 degrees here. Why is that important? You see that blue line? The gradient of the blue line times the gradient of the green line, they should give you -1. So we can find the gradient of the green line. So I'm going to say, so what do I have first? I know I have the midpoint. My midpoint is 3, 5. Next step, I'm going to find the gradient of AC. And that gradient, I can use here, 7 minus 3 over 7 minus -1. It's 4 over 8, which is half. What does that tell me? So let me make it a bit smaller. If that is the gradient of the green line, then the gradient of the blue line, gradient of BD, therefore, gradient of BD will be nothing but -2. There we go. So I can now find the gradient of BD. Not the gradient of BD, my goodness, I can find the equation of BD. I know the gradient. Okay? So I am really interested in you seeing that that line is going to cut the y-axis there, and the x is 0 there. So I can already write a point there. I can already write the point 0, comma something. So I'm going to find that comma something. Okay? And I have the midpoint. So I can find, using my formula, y minus y sub 1 equals mx minus x sub 1, where I have a point and a gradient. Okay? So it's a matter of substituting it in. So that's going to be y minus 5 equals to -2 x minus 3. That's my equation already. But let's clean it up. Okay? It's going to be y minus 5 equals to -2x plus 6, and y equals to minus 2x plus 6 plus 5. Okay, with me so far? Therefore, the equation is y equals minus 2x plus 11. Bring that minus down. It's a little bit in the air there. Okay. So there's my equation. What am I learning from this equation of? This is the equation of that's equation BD. If this 11 is here, it means this is the y-intercept. So this point here is 11. Good. Right, but for this part I had to find the equation of BD. Now they say find the coordinates of BD. Let me go take a snapshot of this diagram, our wonderful diagram. Right? I might bring it with some stuff there. But don't worry. I'm only particularly interested in that. Let's bring it down. Now, they say find the coordinates of B. Now, I think we can do B. B is nothing but 0, 11. You agree with me? That's maybe 1 mark. Okay, so you have to find D. Now, D can be tricky. If you say so, but people are saying I'm going to use vectors and so on. You don't have to do that. Okay. The midpoint. Use your midpoint. When you went to B, you from the midpoint to B, let's take in terms of the X, you went 3 places to the left. Okay? So you minus 3. Now you're going to go 3 places to the right. So you're going to say 3 places to the right. What does that mean? It means I'm going to say 3 plus 3. Okay? For my X stuff. And then the Y, well, if you now look at going from here all the way upwards, right? All the way upwards. You went from a 5 to 11. How many places did you go upwards? Well, you went 6 places upwards. That is 11 minus 5. You went 6 places upwards. Now you're going to say, I'm going to go 6 places down. 6 places down. Downwards. That means whatever my Y value is at the midpoint, I'm going to minus 6. Okay. So therefore, the point D, 6, comma, negative 1. There you go. It is straightforward. 6, comma, negative 1. There are many ways, but there's no need. Just use the diagram. Work from the midpoint. That is the D, and that is the B coordinates. Right. It has been a handful. I must say, I was intrigued. I decided let me just play around and work out this question paper. It comes to the end. Of course, in the question paper, you have got all the formulas that you can get used to, how to find, arc length, and so on, to your benefit. But as an AS level student, you should have done quite enough for you not to struggle. But you can always go to the formula whenever you are stuck. This is going to be available, and you can request, and I can make this PDF available for you as you prepare for the examination, or as you are thinking of doing AS level. Okay, the objective will be to do all the question papers of AS, and this is 2025's paper 1. The only one that is needed to put on my channel is 2025's paper 2. Good luck, and see you